Hi, I'm Andy Dansby, and today I'm going to show you how to debug or disassemble interrupt mode 2 on the ZX Spectrum 128. It's fairly easy. So for this example, I am going to use SpecEmu, great emulator with a great debugger in it. So as you can see, I got SpecEmu up and running. I'm going to open up a game. So we're going to go with the Adams family. So what I'm going to do is I'm going to drag and drop over here to my emulator. Now, before I do anything, load the game or anything, I am going to hit escape right here to enter in the debugger. You can also enter in the debugger by going here to monitor debugger. Okay, so we're going to want to view some things here. So we're going to go here to view. We want to view the Z80 registers. We're going to view the memory. Memory is handy because it shows you the stack. And we also want to view our breakpoints. Now I'm going to remove these breakpoints that I already have in there. Start over from fresh. So first thing I want to do here is debug run until. We're going to choose opcode interrupt mode 2. Okay, so what this is going to do is this will load whatever program we put in there, in this case the Adams family, until it sees interrupt mode 2. Once it does, it will launch back into the debugger. So I've already dragged and dropped the game in there. I'm going to press enter for the tape loader. Shows you a nice screen. We're going to press enter at this point. Okay, there we go. It has encountered interrupt mode 2. Now, what we're looking for in interrupt mode 2 is the IR register. So we're looking at the first 2 digits of the IR register, so the I of the IR register. We're going to copy that. Okay, so we're going to set a breakpoint right here where it has interrupt mode 2. So we're going to toggle the breakpoint. As you can see, it hit the breakpoint right in there. Now, we know that at this point, B9 is the pointer to the vector table. So what we're going to do to finish out the vector table is we're going to put in B9, 0, 0. So it always starts off at the first 2 digits, and then you add a 0, 0 to it. We're going to add that. And if we go there and just double click on there, okay, now we can see this is our table. This is our vector table. Even and then odd number. So it's going to be 5B, 5B, and that's the address it jumps to when it hits interrupt mode 2. Now, interrupt mode 2 always kicks in at the end of the frame. So that's 50 times a second. So we're going to look for 5B, 5B. So we're going to hit pound 5B, 5B. We're going to add that to our table. If we double click that, we see a handy little jump right here. That jump, if we hover over it, it shows you what code it runs when it jumps there. So it's jumping to A03E. So if we click on A03E, we'll set another breakpoint right here. Toggle breakpoint. Okay, so the flow of this, and if we go back, I'll show you the flow. Okay, so the flow of this is it hits interrupt mode 2, and when the interrupt happens, again 50 times a second into the frame, it will jump to this B900 address right here. The B900 address says, okay, we're looking at address 5B, 5B. Now, the reason it has, and it's going to have quite a few entries in here, it goes all the way to right here, BA00. And all these are set the same. Now, the reason it does that is it's a table. So in theory, if you have a hardware peripheral in there and it throws off this last two numbers here, it will look up anywhere within that table and pull to that address. So let's go back to the flow again. So it hits that. The program continues to run, and then at the end of the frame, it will say, okay, let's pull up that B900. Let's look up at the table. The table is going to be 5B, 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 jumps to right here, which is just a simple jump address. It will jump to this code, and it will enable interrupts. Right there. And then it returns back to the calling code. So that's a quick, simple interrupt mode 2. Now, how does it get this B900 address? Well, that usually happens a few steps above that, right here. So what we're doing, just before it calls interrupt mode 2, it sets the A register to B9 and then copies that to the I register. So we can see that in action if we toggle a breakpoint right here. And I'm going to close out the debugger. And as we see, it's going to pull up to that every single time. So for right now, I am going to disable that so we can, and we will disable that one. There we go. Okay, so I'm going to exit out of here, and I'm going to show you how that I register is set. So with our current breakpoints, we're going to load the game again. Press enter at this point. All right, so here we go. So it hits this A register. The A register is going to be set when I step into it. The A register is going to be set for B9. So let's look at that A register right up there. We'll step there, B9. Now it's going to load the I register right here with the value of the A register. So we'll step right there. All right, now we see that's changed to B9. Now it hits interrupt mode 2 and continues on. There we go, there's our game. Now, let's do that with another one, because I'm not necessarily thrilled with that particular example. So let's open up another game here real quickly. Let's go for Hudson Hawk. Okay, so I'm going to drag, drop here. I'll close that down. We're going to go to monitor debugger. Okay, so we see our memory, we see our registers, we got our breakpoints. Going to have different breakpoints here, so I'm going to remove them all. We're going to debug run until opcode interrupt mode 2. And we are going to load up Hudson Hawk. All right, so again, we see that we stopped on interrupt mode 2. We are going to add that to our breakpoints. And again, if we scroll up a little bit, we'll probably see where the I register is set. And actually, I'm not seeing it. So it's got to be set somewhere else. Don't know exactly where at. I haven't debugged this, but there's another way we can do that too. I'm not going to get into it right now. So DO F9 is where our register is set. Now that is set to #80. That's our, in fact, I'm going to copy that. I'm going to paste it. So pound 80, which means it should be pound 8000. We'll add that and we'll pop over there real quickly. There we go. There's our vector table. In this case, it's going to be pound 81. Add. Okay. So 50 times a second, it's going to look up that register address. In 8,000, it's going to say, okay, we need to pop to 8181. Pops to 8181, and it disables registers. It calls a routine. It enables registers and returns. Now, let's look at this because I like this particular example. Okay, so what it does here is it pushes these registers to the stack. It loads A with that address right there. It does an AND, pushes it. So it runs our routine here. What our routine is, I haven't disassembled, so I'm not exactly sure. It's probably sound, but who knows? And then it pops from the stack back onto the registers. That's kind of neat to watch. So let's actually kind of watch that. Okay, so I am going to go back to where we go to interrupt mode 2. We have everything really in place to kind of trace this out. Okay, so we're in interrupt mode 2. I'm going to exit out of our debugger. All right, so now we see that it pulled up 8181. Okay, it's going to disable our interrupts. They're already disabled, but I guess it just does this extra step there. So we'll step into that. Registers or interrupts are still disabled. Okay, we're going to call our interrupt mode register manager. I'll call it that. It's probably not the official name. We're going to step into that. Okay, so now it's going to push the IX register to the stack. So here we go. Here's our IX register. And what we should see at this point is that stack pointer pushed with that value. So we should see pound 8226. So we're going to step in there, and there we see it, pound 8226. So the value of that register is pushed onto the stack. We're going to step into the second one. It pushed HL026D. Here it is right there. We're going to push DE, so we should see 5004 pop on that stack. And step. There we go. We're going to see BC pop onto that. 7FFD, or pushed onto that, I should say. There we go, 7FFD. And we're going to push the AF register. There we go. So it showed right here that pushed it onto the stack. Okay, now we're going to run these commands, which means we're going to load the A register. We're going to AND it, and then we're going to push that number 0710. Here we go. And we're going to load the A register with the value 3. Okay, now I'm going to skip past these because this is probably more of a detailed routine that might take a while. So I'm going to go here to where this has this pop AF, and I'm going to right click, run to here. Okay, so I sped up through those routines. So now we're going to pop AF off the stack. So 0710 should pop here into the AF. There we go. And then it's going to call another routine. Well, I'm going to skip past that because I'm not exactly sure what it does right now. So I'm just going to run to here. There we go. Okay, now we're going to pop AF, which is the 6F2C. That should pop over here. There it goes. And it does indeed pop BC, 7FFD. So 7FFD should pop up right in here now. And it sure does. DE is going to be 5004. HL is going to be 026D. There we go. And then the IX we will see with 8226. And there we go. And then we are going to return. Now, when we return, we've returned back to this group right here, which at this point, it's going to enable interrupts. So we should see our interrupts right here change. Boom, there it goes. And then it's going to return back to where it came. Okay, so that is how interrupt mode works in Hudson Hawk. So I'm going to get rid of all of my breakpoints. And we can hear our music playing. Okay, so I'm going to get out of there. And we'll find this common with just about any 128K program. We're not going to cover 48K because they do some tricks with that. Let's see, where can I look at next? How about where time stood still? That's a good game. Here we go. We're going to go to our monitor debugger. Beautiful. We're going to run until interrupt mode 2 takes place. Okay, you're going to drag and drop. Press enter. All right. Here we go. Here's our interrupt mode 2. Toggle breakpoint. Now, here we go again. I'm going to scroll upwards. Now, what I like doing sometimes is this. I'm going to toggle the breakpoint right there. So, when this particular part of the program is pulled up, it disables interrupts. It sets our stack pointer to BFFO. We're going to load our A register with #A4. We're going to load the I register with the A register's value, and then we're going to switch into interrupt mode 2. Okay, so I'm going to get out of there, and we're going to load her up again with our current breakpoints. Okay, here we go. Loading where time stood still. Beautiful. Okay, now as you can see, as this program is entered, our interrupts are enabled. This will disable our interrupts, and if I step into it, we will see the interrupts are now disabled. I'm going to move our stack pointer to BFFO, and when that happens, we should see our stack pointer right up here change. There it goes, BFFO. We are going to load the A register right here. That will change to #A4. There we go. And then that's going to load the I register with the value of the A register. So we'll see that. Here we go. It's going to enter interrupt mode 2, and we will see this change, IM interrupt mode. It changes from 1, and it's going to go into 2. And now we're going to enable our interrupts. So the interrupts right here are disabled, and now they're going to be enabled. Okay, so we know our vector table is going to be at 8400. So down 8400, add. We will pop over to 8400, and we can see our vector table says, hey, we're going to be running at BEBE, add. Well, goodness gracious, here at BEBE, this is our register manager for an interrupt. So I call it interrupt mode register manager. Again, not probably the right name for it, but that's what I like to use, which disables the interrupt starting at first, but if they're already disabled, it just takes that extra step. Okay, so we're going to push the value of HL Here we go. That's going to go into the stack right here. So we'll step into that. 4408. Yep. We're going to push DE to the stack. 4409. We're going to push BC to the stack. 13F7. We're going to push AF onto the stack. 0044. Now we're going to exchange this and this. See, isn't that neat? So this is our shadow register. This is our AF register. Let's swap the two. And we're going to start pushing other values there. So we're going to push HL, DE, BC, AF. Now, this is the routine that it runs during the interrupt. Again, I'm not exactly sure what this routine does. I haven't gone too deeply into it. So I'm going to right click and I'm going to run to here. And now we're going to pull them off the stack and put them back where they came from. Okay, we're going to start off with AF, and we shall see that change. BC, we'll see that change. DE, we'll see that change. HL, we'll see that change. We're going to exchange. And we are, again, popping other values on there. AF, BC, DE, HL. We're going to enable our interrupts again. They're already enabled at this point, but it just makes sure. And then this RETI, that is return from interrupt. So what that does is, obviously we're in here only because we got shot in here via the interrupt. This says RETI says let's return back to where we came from before this whole interrupt started. So we'll step into there. And what we'll see is it steps into the LDIR, which basically is a copy block. So it copies a bunch of information. And there we go. That is how the interrupts work on Where Time Stood Still. And I think that pretty much covers everything for right now. Thank you for watching.